Hello there. This is section 2.6, last section of the chapter. Not too terribly hard of a section, but just some things we want to make you aware of. We're talking about properties, and the first three are the reflexive property, symmetry or symmetric property, and transitive property. So just kind of real basic here. Let's take a little vocabulary and talk about the reflexive property. And I'm just going to abbreviate that. The reflexive property is exactly what it sounds. If you look in a mirror, what do you see? You see your reflection. So basically, if segment AB is going to be equal to segment AB, or angle A, let's just say angle A, will be equal or congruent, either one, to angle A. It's the same thing. So anytime you see two pieces that are completely identical to themselves, it's a reflexive property. Okay. Now you have another property called the symmetric property, or symmetry. Symmetric. Now the symmetric property is pretty simple as well, as if we said, okay, so AB, segment AB is equal to segment CD. Well then, if you flip it over, CD is equal to AB. It's kind of like if you think of a line of symmetry. A line of symmetry would have to do with, and you don't have to write this down, I'm just going to draw this to show you. If you have a square, where is there a line of symmetry? Well, it'd be right down the middle, because if you folded the shape on that line, you would get the same thing on both sides. Kind of like your face. Maybe not mine, but if you drew a line straight down the center of your face and folded it over, it's symmetrical. And here on each side, half a nose and eye. My nose is a little crooked, so it may not quite be too symmetrical. But that's what we mean about the symmetry property, okay? Now the last property we want to really talk about here is the transitive property, okay? Transitive property. Okay, the transitive property is basically going to say this. Okay, if segment AB is equal to segment CD, and segment CD is equal to segment EF, okay, now this is kind of like yesterday in 2.5 when we were talking about those true statements at the end. You look at the part that's in the center, and you kind of cross those two out, okay, because, whoops, let's put that back, because the CD is what's linking everything together, so therefore we could say that AB is equal to EF, okay, and that's the transitive property. You basically got three pieces to this puzzle, okay. The first and the second are equal, then the second and the third, which then means the first and the third, which is what we have here, must be also congruent to each other. So those are the three main properties. All right, so now as we go up here to example 1, we're talking about naming properties. Okay, so for example, let's call this A. If segment GH is congruent with JK, just kidding, then JK is congruent with GH. What property is this? Okay, if you look here back to the left, which one of these might kind of match up? Okay, if you're thinking it's the symmetry, you're right. All right, symmetry. I totally spelled that wrong. Need another E in there. There we go. Okay, so that's A. Now let's talk about B. We're going to do 3 examples here. This is a toughie. You got DE is equal to DE. Now again, which one do you think that might be? They're identical, looking at themselves in the mirror. That's right, it's the reflexive property. And the last one for this example, ooh, that's kind of ugly, is, okay, so we got angle P is equal or congruent to angle Q. And then we have angle Q congruent with angle R. So therefore, angle P is congruent with angle R. Which property is that? Look at who's in common, linking these 3 together. There's 3 different parts, and it's the transitive property. Okay, whoops, this is the transitive property. And basically meaning you've got P and Q here, but then Q and R. So Q is the part that's linking them together, which in the end means that P and R must also be equal to each other. Okay, but this is the one that's in common, all right? That's why it's the transitive property. All right, guys, now we're just going to do an example here in number 2 to kind of talk about how do we use these properties, okay? So I'm going to draw a little picture of a line segment. This is M, Q. This is P. That's N. Now, N is the midpoint of the segment MP. Okay, so he's the midpoint, meaning he's splitting it in half, right? So, if he's the midpoint, all right, of that, and then P is the midpoint of N to Q, like that. So N and P are each midpoints. N is from M and P, that first section, and P is the segment, or the midpoint, of NQ. So, all right, we want to show that MN is equal to PQ. We want to kind of prove that. So in order to prove this, we're going to kind of take some steps. We're going to start with MN is equal segment MN to NP. So this little section is going to be equal to that little section right there, okay? Then we could say that NP is equal to PQ. And the reason why we can say both of these is because they're midpoints. So we just say, like, your reason would be definition of midpoint. And then lastly, to show what we want, all right, to prove that, it would be the transitive property, okay? The reason is, again, just like we talked about with the transitive property, you got NP with MN and NP with PQ. So therefore, the two ends are going to be equal to each other. And that's why. That's your connection. This NP is involved with both the beginning and the end. Okay? So that's kind of how we can use these properties. Okay, the last section here, we're talking about congruent supplement theorem. So basically, we're going to start with here's angle 1, here's angle 2, and here's angle 3. Excuse me. Now, we're going to tell you that angle 1 and angle 2, they're supplementary to 3. Meaning, if you add 1 and 3 together, or if you add 2 and 3 together, they're going to be supplementary, meaning they're going to equal 180 degrees. So we want to prove or show our final answer, or basically what we're looking to solve is 1 congruent to angle 2? Are those congruent? So here's what we can go with and start with. Our first step, I'll just call this step number 1, is that we know that angle 1 plus angle 3 would equal 180. And again, we know that because we're defining supplementary angles. And then secondly, we can say, okay, they told us in the directions here that 1 and 2 are supplementary. So angle 2 plus angle 3 also equals 180 degrees. So we could set up an equation, basically. This would be like step 3, that angle 1 plus angle 3 is going to be equal to angle 2 plus angle 3. All right. And then if you were to solve, you could subtract angle 3 from each side here. And those would cancel out on both sides. So basically, we're left with, in the end, that angle 1 is equal to angle 2. They are congruent angles. And mainly, you just kind of use some common sense. We're told in the directions up here in the beginning that they were supplementary to 3. So it doesn't matter what angle 3 measures. If they're going to be supplementary, it means they have to total 180, which means if 1 and 2, no matter which one you add to 3, equals 180, then 1 and 2 have got to be the same. All right. So all this down here that I did, it gets a little wordy, it gets a little challenging. All right. But as we work through some practice problems and things like that together, I think you'll start to catch on. All right. But I think in summary, if we're going to do the summary, I think the biggest thing is understanding these properties that we talked about up here: the reflexive property, the symmetry property or symmetric property, and the transitive property. Okay, those are the 3 biggest things that I think you need to take from this session today. All right. Have a good rest of the day. See you later.